Here's the examples of law of total expectation. First, you want to find the expectation of sine x plus y, and also I give you the distribution of x and also y given x. So first of all, we just have the expectation of sine x plus y. Now you recognize this is a two random variables. So if it's two random variables, I should have double integration, and I should also have a joint PDF dx dy. Then the joint PDF the joint PDF, I cannot change the color. There you go. The joint PDF could be written down like f y given x times f of x. Or I can write it down x given y times the PDF of y. Which one I will use? Because I am given y given x in the question, so I will use this. So that means this also equals, I still put it on a double integration here first, sine x plus y. Then I will use y given x fx. Here is also like y given x d dx dy. Now if you see this term here, here, and here, these three parts I can have the expectation of sine x plus y given x equals a fixed point. Right. And times the fx dx. Here the x is still normal distribution, so it's from minus infinity to infinity. So see this again. The expectation of sine x plus y given x equals a fixed point, I can also write it down to the integration form. I keep this the same times the PDF. What kind of PDF? Conditional PDF. Yeah. So this is conditional PDF. So why do we want to do this? Because in this part, right now in this part, let me go to the next page. So now we have we have sine x plus y x plus y given x equals to x times fx dx. Now next step, I want to extract this form. This is the integration sine x plus y times the y given x dy dx. Oh, fx dx. And this, we know it's uniform. So it's from x minus pi to x plus pi. And now, since it's uniform, this goes to 1 over 2 pi. Right. And then observe sine y dy. And it's doing like a cycle. So actually, those goes to 0. And then finally, this just 0. Next, we want to find the probability of y less y. And I give you x is uniform distribution and y given x is exponential. So what does this mean? It's just like a CDF. So it's a CDF over y. And also I can express this as from minus infinity to y. F, because it's to y, so I do like f z dz. That's not good. I still put y. How about y prime? Don't be confused, that's just the parameters. So this from minus infinity to y, I can have, again, we know fxy equals f y given x dx, or x given y dy. And now we have y given x, this is given. So we will choose this. Fx, fy. So that means this fy is the conditional probability of y given x times fx dx, then dy prime. This is also the marginal. This is also the marginal marginal PDF of y. So we won't use this anymore. Just use the marginal PDF. Well, if I would like to make it clear, fy marginal PDF is fxy dx, then this fxy could be fy given x, fx dx. So that's why. Oops. So that's why we have this. It's also on the marginal PDF. Now we have all this information, and from here, then we can plug in. First is the y given x and fx. What is y given x? The PDF of y given x is exponential. Exponential x. The parameter is x. So it is x, well, and x is uniform. So here it should be x times e to the minus xy prime dy, well, dx, times x is uniform, so f over x is 1 over 1 dy. Actually, you don't need the 1 over 1 because it's just 1. And how about the limit? Here is 0 to 1. X is always from 0 to 1. Then I diff the following process, then you can know, because now I have already simplified to here. Then you can take the integration by parts to find this integration, and then finally find dy. Okay. Number 3. Is the expectation of x times exponential y. So again, we just write it down. The x e to the y. Now you're probably familiar with the law of expectation, of total expectation. So we can immediately write it down like this is just the integration of whatever it is here given x fixed point times fx dx. And now this one is, since y given x is a normal distribution, so it's normal distribution here. Normal distribution, so xe to the y given x dy, then times fx dx. Now we need to find what is this. Okay, so since it's dy, I don't need the x, so I put the x outside the integration. So ey, this y given x conditional PDF is a Gaussian, so it's Gaussian. Gaussian, I have like 0 mean, and the variance is x squared, e to the minus y 0 mean, so 0 mean, and 2x squared dy. Now next page, I have the same form, x squared, but e to the y times e to the minus y squared 2x squared dy. I want to make a perfect square. So here finally you will have exponential minus y minus x squared dy. And also I will have the outside terms is exponential x squared divided by 2. So now this is just a normal distribution with x squared mean and x squared variance. And take the integration, this is 1. So now I have x times e to the x squared divided by 2. This is just for this part. So it's x times e to the x squared over 2. So now is minus infinity to infinity x times e to the x squared divided by 2 fx dx. And now x is uniformly distributed, so it's minus 1 to 1. And fx is 1 over 2 times x e to the x squared divided by 2 dx. And this is odd function, so which is 0.